One of my favorite lenses for film and digital photography is the Zeiss Planar, or the Carl Zeiss Planar. This particular lens was made under license by Rollei, but it's still a planar, and it's marked as planar. This is the very common f1.8 50mm lens. There were several versions of this lens. The earliest lenses actually were marked Carl Zeiss, and these were mechanically a bit different in that they had all metal focusing rings and aperture rings. When production of lenses and cameras moved to Singapore, the construction of the lens changed. They stopped being branded as Carl Zeiss and were now branded as made by Rollei. It otherwise is the Carl Zeiss planar design, a true planar still. One of the changes, and this was a reflection of the shift in the industry, was the move to using rubber focusing rings and aperture rings. And that's all good and fine until the rubber gets hard or chipped or simply disappears. And that seems to be fairly common with this particular model. I've had a couple of lenses like this in which the focusing ring has gone missing. What seems to happen is there's a rubber glue under here and it will become loose, and then the entire focusing ring then becomes loose and it either is lost, or I'm not really sure what happens. But in any case, this will be, I think, the third lens I've had, the third made by Rollei planar that I've had that is missing a focusing ring. One of the advantages is that it makes this lens very inexpensive. If you're buying this for digital use, most users will go after the Yashica Kyocera Contax branded lens, the ones that is actually marked as a Zeiss lens. Whereas you'll often pay maybe $150 to $200 for the Yashica Kyocera lens. With this one, you will often only pay maybe $80 to $90, maybe $100, and this lens was actually quite a bit less than that. Because it's missing the focusing ring, and I only paid $45 for it. So what are we to do about this? Thanks to the global marketplace, the one thing that you can now do is you can buy replacement focusing rings. However, there are plus and minuses to that, and we'll look at that right now. So I think I paid $3 for these. Very inexpensive. You're going to see this one's ribbed, right? And obviously it is much larger than it needs to be. So it's both wider and it's larger in its circumference. So if I want to use this one, I will have to cut it. I'll have to cut it here and then cut it to specification. Now what about this one? This one is a bit different. It's a little bit of a takeoff. This one doesn't have, this one is sort of like, I don't know, dashes, I guess you could call it that. I looked for the original checkerboard pattern, but I couldn't find any material for that. One source would be for older lenses, older zoom lenses, and those would be those low quality, never heard of the name, zoom lens in which they still have the focusing ring. Often you get those for like $10 or $12, but in this case this was even less expensive. So well, the question is, will I be put off by using this material rather than a true checkerboard material? I don't think so. I think this is going to be fine. So how are we going to do this? First we're going to have to measure the width here. Then we should measure the circumference. Well, the circumference actually, as you know, will be the diameter times pi. Or you can just get something and measure it. If you get a string or get a piece of paper and measure it. So first for the width here, let's turn that on. And these measurements would always be in millimeters. So it looks like that is 12 millimeters wide. And let's do the diameter. So the diameter actually is 60 millimeters. So if we were to take 60 millimeters and multiply it by pi, because that should give you the circumference, 188.5 millimeters. Now the question is, do I want to make that slightly shorter so it's a snug fit, or do I make it exactly 188.5 millimeters long so that it fits exact? Of course, if you make it a snug fit, if you want it slightly snugger, maybe you make it 188 millimeters and then pull it tight. I don't know. One thing's for sure, I'm either going to have to cut this piece or I'm going to have to cut this piece. So I have to decide which it's going to be. And I think, because I can tell, well, let me just show you where 12 millimeters is. All right, that's going to be close enough for what we want. So 12 millimeters places us squarely in the middle. Well, not even in the middle. I guess you could say that's about, what, 3/4 of the way through this second row. So maybe this works best because there's no interruption of a pattern, because there is no horizontal pattern. It's simply a vertical pattern. So I'm going to have to look at two things. One is, I thought maybe that there would be a seam in here, but there isn't. Right? So I think I'm just going to have to pick a point here and just cut it. Like I said, luckily this was only $3, so it's not like I'm I'm ruining a $30 piece of material. There we are. Now I really want this to be 12 millimeters wide. Now you can see a little bit of nub right here, so I think I'll get in here and just trim that. Actually, we're going to recut this. Now, you can see the challenge of doing something that's 12 millimeters wide. So first of all, we want this to be 18.8 centimeters, or really 18 millimeters, 18.8 millimeters. So if I cut it to 19, that'll be right here. But let's take a real quick look, see if I'm correct on that measurement. And I am. Okay. So good. So let's go ahead and cut this to 19 millimeters. Because we can always shorten it, but if it comes up radically short, you can't really lengthen it. Now here's where I'm going to use a guillotine cutter. Smaller version. It's like it's like that big paper cutter that I have, but it's a desktop size version. So why do I want to use this as opposed to just eyeballing it? I think that says it all, right? First of all, let's give this a proper trim. Well, maybe not. Okay, where was our 19 millimeters? Oh, yes, here we are. 19. Ah, let's take this and wrap this. Make sure that we're still good. And we are. Now, here's the big challenge, right? We want to make this 12 millimeters wide. Now, is that something that I'm going to be able to cut freehand? Probably not. So I think I'm going to have to measure and mark this several spots. I don't have a fine tip marker, so that's going to be 12 millimeters. Let's see if that's correct. See, and if you, as you can see, that's actually a little slightly under. So we're going to fast forward through this part and I'll explain what I'm doing here. So right now I'm just making some cuts in the rubber. And so I'm measuring several times. And so the idea is that I get as accurate cut as possible. The one difficulty I ran into is trying to cut rubber. And so first I tried the guillotine cutter, but that didn't work. So I got a piece of cardboard so I wouldn't cut through to my table because, you know, I just don't want to damage that tabletop. And here, if you notice, my cut doesn't seem to be correct. So I had to measure again. And then checking with the lens, of course. And so now it does seem to be correct. So I'm cutting. And I was trying to do it with multiple passes using an X-Acto blade. It just wouldn't work, so I ended up cutting it using scissors. And I think the challenge of using scissors is you never get a really straight cut. Also compounded by the fact that it's sort of a thicker rubber material, so I had to go back in there and trim again. Now it seems to be pretty tight, and I think it worked out fairly well, although there was quite a bit of cutting, as you can tell. Okay, so now we're just down to this, and the question is, how are we going to attach this? Where's the seam going to be? If we were to think about it, the seam should be where there isn't any markings. Also, if you recall, there's a straight edge, and that'll be this side, so we're going to put the cut edge down. Hopefully that'll be less noticeable. So the seam, I would say, should go probably right around here. There's a slight amount of overlap, so I think I'm going to trim right here. Now what's going to happen is, as I glue this down, it's going to shift around a bit because it's going to take a bit of time for the glue to set. Which leads to the next question, what is the best way to attach it? Use double-sided tape, perhaps. Use a contact cement, quite possibly. Or maybe a craft cement. A bit difficult. This, as you can see, is sort of a smooth rubber. It doesn't appear to be coated with anything, which is both good and bad. I have several types of craft cement. Here's one made by Elmer's. It's used, what's it used for? Photo safe, don't care about that. Transparent with double point. I also have this liquid glue, advanced adhesive solution. Doesn't really say it advanced in what. If I was really crazy, I'd probably use something like this, which is a 3M extreme mounting tape. I think the issue with this, though, is the thickness of the tape itself. And you can see the challenges that it presents. We also have this, which is Scotch brand permanent double-sided tape, and I think that's an option I probably will take a look at. Next up, we have this spray adhesive. This is a contact type cement, and so what you do is you would spray this surface, and then you would spray this surface, allow it to become tacky, and then bond the two together. While this is probably, I probably can just get away with just spraying this surface, I can tell you that this is also the messiest to work with. So I think what I'll probably do is use the one that's messiest to work with, which is here. And the reason is I think it will provide the best adhesion. Hopefully this will prevent any overspray. Okay, allow to dry 1 to 3 minutes. And then it gives you up to 10 minutes to reposition. But as you can see, it's still pretty wet. And I really try to put on just a thin layer. So we will let this dry for a moment, and then we'll be back. Okay, so it's been a couple minutes, and let's go ahead and attach this to it. So remember, we have two sides. We have the real straight edge side, and then we had the cut side. And I can tell that this lower side is the cut side. Now we want this seam to be somewhere between here and here, roughly in the middle. So we can just place it right up here, and now we begin just working it a bit. So I'm just pressing in so it doesn't extend up past the edge of the lens barrel on either top or bottom. Okay, I think that worked out pretty well. Feels pretty uniform here. You can see the small seam right here, but if we push these two together, now it almost becomes not visible. I don't want to say invisible, but it's almost not perceptible. How about that? Imperceptible. See, so now we can take this, we can mount this to an adapter. We can mount this to one of the Rolleiflex SL35 cameras, or we can mount this to an adapter and use it for digital. Either way, you now have a fully functioning, a very clean, by the way, planer. This is a Zeiss design. I can't remember the number of elements, 5 or 6. Carl Zeiss says on its website the planar is the most plagiarized lens design in history, and in fact has served as the basis for most or nearly all, I would say, high-speed lenses. High-speed 50mm lenses. The planar has been used on many cameras, been used as the basis for the standard 50mm lens for nearly all cameras since, I would say, the 1970s. It also has appeared on the twin lens reflex cameras. It's been used on Hasselblads. It's also been used on Rolleiflex's line of medium format SLRs. All right, very good. I think I'm real happy with how this came out. Where's the seam? Oh, there's the seam right here. And if you look real hard, you can see it. And you can see it simply because it's slightly, the width between the ridges is slightly wider. But to the naked eye, or to a quick glance, you really aren't going to notice it. The one thing is that it does seem to be popping up a little bit past the its channel, just a couple spots here and there. You know what? I'm real happy with how that came out. So, $45 lens, $3 focusing ring material, and in fact, I still have left over this one for some other purpose, whether it be for another of these cameras or for some other lens that's lost its focusing ring. There you have it. A true planar lens, now ready for use on film or digital, and looks much better, especially when you compare it to its original state when I pulled it out of the box. So that brings us to the end of this video. If you have a comment or you'd like to leave a remark, you can do so below, or you can send me an email at contact@camera-talk.net. You can click that icon in the lower right corner of the screen for more content about cameras and photography. And I hope that you'll join me on my next video.